at Fully Charged live in Vancouver, BC, Canada. There is so much amazing stuff to see and do. And one thing that really caught my eye was this. This is not a production electric vehicle. It's not a vehicle that's coming to market, but it is, most importantly, a vehicle that has been built by a team of engineering undergraduates at UBC here in Vancouver. UBC obviously stands for University of British Columbia, and we have two amazing team members to talk to about it today. And the first person that we're going to interview captured my attention earlier today with their enthusiasm, with their joy for engineering, mechanical engineering, and for the race car, and that is the lovely Cait. Cait, tell us a little bit about your role on the team and how long you've been in this Formula race series.
Yeah, of course. So on the team, I am one of the drivetrain members. I've been on drivetrain since I started the team, which was 2 years ago now. So I help out with everything you kind of see in that back half, including the two motors and gearboxes, drive shafts, and then that's what takes our power out to our wheels.
Now you compete in a North American race series for universities building these cars from scratch. Tell us a little about the race series.
Yeah, so the competition, it's FSA in Michigan. It's in June, and we raced. There was about 71 teams. They're all electric. And we go there and we have to go through a series of inspections. We also have static events. And then finally, if we're able to pass all those, the last thing is the dynamic events. So since we're an electric vehicle, for the inspections, we start off with our accumulator, so our battery for the car. That's our first inspection. Once we pass that, then we are able to move on to our mechanical inspection. Once we pass that, we move on to electric inspection. And then from there, it goes to tilt test, rain test, and then lastly is brakes.
Now, you were telling me earlier on that this car was built from scratch by the team.
Yes.
You had all of the components that you've built, you welded the frame, you designed the gear mechanisms, you've designed the suspension. There are a couple of off-the-shelf components in this, but for the most part, this is all built by the team at the university.
Yes. So we are a slightly newer team at UBC. We've been around for about 8 or 9 years now. Obviously with COVID, that affected 2 or 3 years and we had to kind of shut down a bit. I joined right after COVID, so I joined in 2021. So right as we were getting back in. And yeah, so we designed most of the car. We also had some previous members before COVID that also helped with this design. So sometimes it's not always everyone who's on the team. It passes down through generations. So sometimes the older members help with design and the newer members maybe help with manufacturing. So when I joined back in September of 2021, we had already had this chassis welded. Actually, sorry, this was for our last car. We make a new car every year. So last year we had the chassis built, but we had very little on it yet. So we had to design and make sure we had all of those pieces to add on. Like I said, we make a new car every year. There's a couple things we can transfer over. We don't have to completely rebuild everything every year, but there are a couple rule compliance that you do need to redo, including our chassis, which, like you said, we do design and weld completely in-house.
Now, obviously the motors are a very important part of the car, but you were telling me earlier on, you've also got an interesting gearbox system for the reduction gearbox that you played a big part in. Tell me about that.
Yes. So we run 2 Emirax 188 motors and we do rear wheel drive in this car. We use planetary gearboxes. One big reason for that is they're more compact, with the gears now not having to be one after another. They can kind of be stacked with the sun gear in the middle and the 3 planet gears around. So we have a very compact design because it goes right from the motor, and then right next to the motor are our where we shelve both our sun and our planet gears. That, just like I said, makes the design more compact. It also helps increase the torque that this car can handle because the gears are engaged in now 3 spots instead of just 1.
And you told me that the drivetrain's really efficient, right?
Yes, we usually get about 95% efficiency out of these gearboxes, which is incredible. We designed most of these gearboxes. We did, however, use a company, Delta Dynamics, who helped us manufacture the gears specifically, just because that has a very low tolerance for any issues. And we are a student team, and we have a lot of amazing members, but we are limited in some of our ability to fabricate some of these designs.
Right,
so
you don't have the full industrial level fab outfit that you might have if you were in the industry.
Exactly.
The motors are putting out about 80 kilowatts. The battery pack's putting about 80 kilowatts. We're going to actually chat to someone else in your team about some of the electronics that we've seen put in this vehicle. But the amount of power that this thing produces compared to the weight is mind-blowing.
Yeah.
Talk to me about that.
Yeah, so this car weighs 224.1 kilograms. And like you said, we run 80 kilowatts out of our battery, which means we get about 0.381, I believe, kilowatts per kilogram.
That's incredible.
Yeah, which is super great for our car. We definitely have a lot of power in this car. We can do 0 to 100 in about 2.6 seconds, which is obviously pretty incredible and something we're very proud of on this car. And that has to do with how efficient and how effective our gears are and the power we're outsourcing from our battery.
And I'm going to note here, because I know that there's going to be a lot of audience members watching in the US and the UK. We were talking about 100 kilometers per hour, not 100 miles per hour,
yes,
right?
We are.
So the car has to go through a lot of engineering verification. It also has to go through different handling tests. And you have several different drivers who take part, right?
Yes. So for competitions, we usually have about 4 to 5 drivers for competitions, because there are 3 dynamic events at our competition, one being acceleration, one being autocross, and the third one being endurance. So we like to have, you have to have at least a different driver for each one of those, and you can have a driver do 2 different events, because in some of them you can do it twice. So in acceleration, you get 2 attempts at your acceleration. And for example, for endurance, it's an 11-kilometer course. It's a 1-kilometer course you do 11 laps on, and then you have to do a 3-minute driver change, and then it's another 11 kilometers. So for that one, for example, you need 2 drivers just right off the bat to complete it. And yeah, so all of our drivers come again from within our team. We're mainly consist of engineers, but we do also have a business team, which is more of our business members, and we allow everyone to get a chance to drive the car. This year, which was really fun, we got to go-karting as a whole team, whoever wanted to, and that was kind of one of the ways we used to see who our faster drivers were going to be. Exactly. Yeah. It's, you know, not always the most effective, but it was a way for us to tell without obviously putting people in this car that's very fast and, you know, a little bit more of a risky situation that we don't want it getting damaged. So that was a really good way for us to kind of see who had the speed, who had the control, and who we could trust to put in this car, because, you know, this is a really incredible car, but it also took a long time to make, and we don't have spares for a lot of things, so we don't want to risk any damage coming to the car, so we have to be really careful of who we're putting in behind it and where we're going, and making sure it's protected at all times.
So Cait, it's been a real pleasure to talk to you. Before I go and talk to your colleague Joe, who's going to talk to me about some of the powertrain stuff, I would love to hear why you got into engineering.
Oh, I'd love to tell you about it. So I have always had a love for driving. I've been obsessed with Formula for a long time. My grandparents were race car drivers, so that's always been an inspiration of mine. When I decided to go into engineering at UBC, if I'm being 100% honest, I actually didn't know this team existed. So I just kind of thought I was gonna, you know, go through my degree and not get much hands-on work out of it until after. But first day of my first year at UBC, I see this team standing out and, you know, helping recruit for new members. I go up and they tell me about the team. They tell me, you know, what kind of stuff they work on, what kind of skills I'll be able to learn throughout the team, and just a little bit about the team community. And I instantly fell in love, and I knew right then and there that that was something I wanted to do. I applied right away. Luckily, they accepted me, and I've been on the team ever since. It truly is such an amazing group of people. The community is so great, and it's a very challenging team. This car is not easy to make, but the people really make it worth it. And I, could spend hours in the bay working or just chatting with the people in there, because we really are like such a family working on this, and we've gone through so many struggles together trying to get this car to where it is, that it's really bonded us together. And honestly, my favorite part about the team is honestly just the community and the time we get to spend together, and then obviously being able to show our creation off and take it to competition and do all that together is just something that I would never trade the world for, and I'm excited to continue on this team until I graduate.
I'm assuming that you want to go into the motor industry, maybe get into a race team, moving forwards.
I'm not 100% sure where I want to go yet. I have some interest in maybe doing some battery manufacturing and the chemistry side of that as well, which I'm doing a little bit more in my degree now. So that's an interest of mine. I'd love to be able to do some race car driving in my future as well. If I can do some of that, that would be awesome. But yeah, this has given me skills that will not only help me in the motorsport community. So even if I end up doing something different, I know I can use the skills that I learned on this team to help me overcome really any obstacles.
Cait, it's been an absolute pleasure. I know Joe is waiting in the wings.
Yeah.
So we're going to move over to the battery and power electronics side of things. Cait, thanks very much. Enjoy the rest of the show.
Thank you so much.
Quick camera change, and we're back with the UBC team here. And we've got the lovely Joe, who is going to talk to me about the power circuits that have been designed specifically for this car. This is not off the shelf, Joe. This is full in-house design. So tell me a little bit about your role with the team, and then tell me a little bit about how these circuits came to be.
Absolutely. So for us, we have about 16 circuits on the car, and all of those boards are completely done in-house, programmed and designed all by us. And so what that means is we can really dive down into all the different electrical circuits of an EV and really teach those to our undergraduate team and to the community around us. So for us, that includes, the battery management system, different LV power distribution, our dashboard, sensor data acquisition, and a few of the other, radio systems we also have to deal with.
So I learned earlier from one of your colleagues on the team that you design these boards from scratch in-house. You then send them off to be printed. You get basically fresh boards back with no components, and then you populate the components yourselves. You write all of the code that goes into these systems. I see you've got CAN and bus interfaces on there. You've also got an ARM-based processor in there, and you told me that you're running C code because that's nice compact code that can run very quickly on a very compact board. The quicker it can run, obviously, the easier it becomes to keep everything in order and check. So show me a little bit of the main points of these boards here.
Absolutely. So this board here is our low voltage power board, and basically it has a few different functions. First and foremost, it starts with these two 18650 cells here, and those start up the car before we have confirmed the HV battery is safe. It runs some safety checks, and once it does, we can then switch over to our HV battery and the DC converter inside. Other than that, it has the circuitry to regulate the voltage rail of a car. We run a 24-volt system. And then on top of that, we have the high side drives to do, overcurrent protection. We also recharge the 18650s, and we also set up a 12-volt rail on this for the off-the-shelf components that do require that. So that's kind of the rundown on this board. Other than that, I also have here one of our battery management circuits. So what you can see here is a flexible PCB and a rigid PCB. So the flexible PCB is to really drive down our part count and make our packaging really efficient. So it has onboard thermistors, onboard fusing, and the voltage taps screwed directly to the bus bars. And then on this rigid board here, we have the passive discharge circuitry to balance our pack and also monitor those voltages and temperatures from the flex PCB to make sure everything's working as expected and everything's within range for safe operation.
So you're doing effectively a bottom balancing strategy for this. You're discharging the battery to get all the cells at the same voltage rather than charging them up to get them to the same voltage.
Yeah, that's correct. We do that primarily to reduce cost of our system, and because since we aren't a road car, we can balance, off track and in our shop. And so what that allows us to do is basically simplify what actually goes into the car and not need to worry so much about the thermal management downsides that come with that bottom balancing.
So I heard that your team is actually balancing the pack this weekend back at your campus, which is not far. You're just based off of the peninsula.
Yep.
And you're able to charge it and balance it away from the vehicle, so the vehicle can be doing events like this. You can still be working on the pack. I do want to highlight, I mean, I've seen plenty of PCBs in my time. I am blown away by how tidy this PCB is here and how few vias there are. It's a very tidy, neat circuit. Which revision is this?
This one, we'll call it, I think it's about the fourth one. There were a handful before my time on the team. This was my very first project when I got onto the team, was working with that board. And then we've, of course, done a couple revisions since the one you see that are on this car today.
But, I mean, very, 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 very neatly done. So, I mean, I've seen production vehicle and production equipment that has got less tidy circuit boards than that. So I know, obviously, small-scale production,
Yeah.
you can iterate in a very different way than you can if
Of
it's
course.
millions of units of a particular circuit board, but it looks really, really good. And we've also got a smaller motor here. Tell me about that.
Yes, of course. So this motor is part of our 2-year plan to go to in-hub drivetrain. So right now, as Cait talked about, we have a 2-wheel rear-wheel drive. Within 2 years, we would love to go to an in-hub product. So basically what that means is every wheel has a motor next to each wheel, and a custom planetary gearbox on top of that, so much smaller and less power per wheel, but as a total, we still get up to that 80 kilowatts we need to. This allows us to do a lot more with torque vectoring.
Right.
And so what that means is a different amount of torque to each wheel, depending on the turning conditions, the slip conditions. We can run control loops with the slip ratio of each wheel to make sure we are putting the power everywhere we possibly can without slipping.
And it can improve your handling, it can improve your cornering times.
Yep.
It can also improve your efficiency. So very excited to see how that is also going to work out. And you are currently in the team, but you've just been running an internship. You've been in the US. Tell me about your internship.
Yeah, so I was lucky enough to go down to Tesla Motors for this last 4 months. I worked on some of their circuit design there. For a bit of their vehicle program. And so that was a lot of, a little bit of design, a lot of bit of testing and validation, proving that everything works as intended. And I would honestly attribute all of the skills I have that got me to that internship to this team. Very little of it was, purely class-based. It was a lot more of these extracurricular applied knowledge that got me where I am.
So I'm going to ask you, I asked Cait, why engineering?
It's kind of been a lifelong passion. I mean, my parents tried to expose me to a lot of different things, and I held on to electronics when I was 4 years old and just stuck with it. So for me, it's always kind of been what I wanted to do. And, they've never been able to stop me from doing little projects in the basement, in the garage, up until now. Of course, in engineering school, I get to go a little bit larger scale. But
And the advances that we're seeing in transistor technology in the last couple of years, last decade or so, has been really incredible. Silicon carbide, a decade ago, it wasn't really something that we were seeing much of. We're now seeing that. It allows for more miniaturization, it allows for more power density, and that must be a really exciting moment for you as you prepare to enter into the industry.
Oh, it is. And I mean, we're always going to keep seeing miniaturization. I know, we can speculate about Moore's Law hitting a ceiling, but I don't know, we keep finding new technologies, so I'm extremely optimistic about what we're going to see over the next few years to decades in power electronics, EV design, and really across the board in electronics.
So what's next for you, Joe? After UBC, where do you go next?
I mean, nothing set in stone, of course. My current plan right now is I would love to go back to Tesla Motors. We haven't, of course, worked anything out officially, but that's where I would love to be. They do some really amazing work down there, innovating in the EV field, and I had a great time this summer. Would love to go back.
Joe, it's been an absolute pleasure. Thanks to you and the entire team. Thanks to Cait. I wish I could interview everybody here. I am really excited about this car and the project. I love seeing university teams innovate in ways that, traditional automotive applications just don't have the time and the energy to do. Here's to you and the team, and here's hoping that you get many more trophies and we see that amazing quad motor in a few years' time. come out from UBC's team.
Absolutely. Thank you so much.
And on that note, we are done with today's video. If you have comments, which I hope you do, drop them in the comment section below. You can also reach out to us in the Discord chat room, or if you are a person who uses the federated world of Mastodon, you can reach us there. Of course, if you are a Patreon supporter, leave a nice word or two there. If you want more from the channel, don't forget to subscribe, hit the bell, and follow the links below if you would like to regularly support us with either a YouTube membership or a Patreon subscription. You'll also find links below to our Ko-fi, Bitcoin, and Swag store, as well as that aforementioned Mastodon server. And there's also a link to our PeerTube server. Scrolling on my right is the list of amazing charged up supporters, and shout-outs go out to our V2G Patreon supporters. They are Alan Tupper, Andrew Martin, Bennett Elder, Brophy Wolf, Chris Maxwell, Cyprian Laplace, Dan Blair, Gordon C., Hey Esker, John Tramal, Kyle Fox, Mark Eggleton, Peter Dillinger, Regine Fellows, Sean Tucker, Stefan Fremgen, Stephen Williams, Tesla in the Gong, Paul Bricknell, Tony Moss, Carl Hodgson, Chris Ascenta, Denny Hyde, Lance Schlull, Linda Irish, Mike Weeder, and Paul Nelson. And finally, big thanks to our off-grid supporters, Paul Conway, Kevin Burrabridge, Stephen O'Donoghue, Jim Burness, Robert Flannery, Aaron Hahn, Ellery Hensley, Rory Litter and JP Fagerback, Dave Kitchen, Andrew Glenn, Anonymous Freak, Chris and Michael Johnson, Clay Witt, CPU Freak 101, Eric Neck, Joe Bresney, John Henderson, Laura Reynolds, Marcel Ward, Matthew Jobnack, Nigel S., Reggie Watts, Will Graylin, and of course, Ian. Don't forget that we make videos every Monday, Wednesday, Friday, and Saturday on this channel, plus on a Sunday. If you are feeling chatty, join myself or Cait Walton-Elliott over on Transport Evolved Take 2 for our chicken and garden updates and our Sunday musing. And with that, I hope you enjoy the rest of your day. I will see you soon, and as always, keep evolving.